class. I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today we will be discussing unit number 3, last topic, durability of concrete. So, durability of concrete is very important because that is related to service life of the structures. So, if you see the definition of durability according to the SCI code, American Society, American Concrete Institute. So, what they say? So, durability of cement concrete is defined as its ability to resist weathering action, chemical attack, abrasion or any other process of deterioration. So, concrete get deteriorated as the time passes. They have tendency to go to their original condition, because we have raised the potentiality of cement. So, there is a chances of getting deteriorated as time passes. So, for that the material and mix proportion is specified, and you should maintain its integrity and also protect embedded metal from the corrosion like steel or tendons we are using for pre-stressed concrete. And if it is a reinforced concrete, we can use the either mild steel or high yield strength deformed bar or thermomechanically treated bar. So, that also has been raised, their potential has been raised. So, they also have tendency to go to their original condition. So, there is a process of corrosion. So, if we get the favorable environment for the corrosion, then embedded steel will get corroded, and the volume of corrosion is very high with respect to the original value, around 6 to 8 times. So, that exerts pressure on the concrete, because say let us say this is the steel. If corrosion is taking place, then their surface area will be going on increasing, and whatever the embedded concrete is here, this concrete will start getting crack. So, this will start getting crack because this steel volume going on increasing. So, that also we have to protect. So, concrete structure is subjected to interactions with environment in which it is located. So, environmental factor is very important. So, what are the exposure conditions? So, depends on that. So, different codes has given different exposure conditions. So, Indian standard IS 456 has also given certain environmental conditions. So, environmental condition that we will discuss in the later stage. So, if you see this diagram, so I have discussed here given surface life of a durable structure. So, if you see here, so in this particular graph, this is the service life, this is the design life of the structure. Say I have designed a concrete structure for 70 years, say for building. Okay. So, this is the capacity, this is capacity. So, this is the minimum working capacity of the structure. So, after that our structure will not be fit for service, and we raise this capacity up to here. So, initially we have a 100% capacity here. So, as the time passes and due to the defects in the concrete or corrosion in reinforcement, abrasion, fatigue and other parameters, concrete strength will go down. Okay. So, if there is a more defects in concrete, so you can see here service life say they reduced to say 35 years. If you see many structures constructed in Delhi, due to the durability problem, I am staying in Dwarika, Delhi. So, due to the durability problem, the structure which has been constructed about 15 years back is showing the cracks and severe cracks that needs repair, and if repair will not be done, so within 4 to 5 years that building may collapse. So, why it is happening? due to this defects, premature defects in this one. So, this is a premature. So, it is not going to complete this complete service life. Even the structure has completed their service life, if you want to extend their life. So, what we have to do? We have to repair the structure. Okay. So, we have to repair the structure and increase their capacity. So, as you increase their capacity slowly, once again it will go and decrease. Okay. Similarly, we can go for extensive repair work, so that their strength go to the original condition. The strength go to the original conditions. In that case, what will happen? So, this program So, this will go for some more time and it will go here. So, like this, either you want to invest at a time more money, then you repair here, so that their life will increase, or if we are increasing this some patchwork or some temporary repair work we are doing, then once again you need to repair. So, service life of the structures depends on the durability. So, durable structure will work for this period of time for design life. So, process of deterioration in concrete, so that is due to the sulphate attack, seawater attack, acid attack, ingress of carbon dioxide, chloride, water, oxygen, which leads to the corrosion in the reinforcement, frost action, alkali aggregate reaction. So, all these things mostly say from you can say from item number 1 to 3, sulphate attack, ingress of carbon or frost action, that is directly related to permeability of concrete. If our concrete is more permeable, then there will be ingress of all these component like carbon dioxide, chloride, sulphate, water, oxygen from the environment. So, that will causing the deterioration in the concrete. So, main fact is we have to make the impermeable concrete, and that depends of many factors. Okay. So, depends upon the environmental exposure condition, we need to change type of cement. So, different type depends on the requirement, we have to change the type of cement. So, minimum amount of cement is also fixed. So, minimum that particular for particular environmental condition, either it is a plain cement concrete or reinforced cement concrete, we have to give some minimum amount of cement. And similarly, maximum water cement ratio we have to restrict, because once water will increase, after the evaporation capillary pore will be more. Then cover to reinforcement, if cover is more, certainly ingress of deleterious material will take time to reach that position. Then there is a restriction on crack width in fracture. So, all these things we have to consider for durable design. So, like this I have shown certain structure here. If you see, here is the Bhakra Nagal Dam. So, this is the second highest dam in the Asia. So, this dam may be subjected to different type of problem. So, those problem have to be addressed before the start of the work. Okay. Similarly, here I have a cooling tower for thermal power station. So, here always it is subjected to water. So, that all these things you have to take into consideration, so that deterioration should not take place. So, photograph number 3. So, here is offshore structure. So, this structure is subjected to different kind of environmental problem, like marine condition is there. So, water of the sea is having lots of salt. So, water is salty, then there is a rise in level, and during the high tide and during the low tide water will go down. So, during the high tide there will be a splash on this surface. So, this is due to this splash, also this thing will be under some problem. And not only that, if you see the top structure, there also the environment is like that air is also loaded, wind is also loaded with chloride. Okay. So, all these things we have to consider here. Say this is the structure, this plate number say 4. So, this plate number 4, this is the deterioration we are observing due to frost action. So, freezing and thawing action is creating this type of problem if you have not designed the concrete properly. So, here see here which means there is a flats here. So, this flats will be their air will be although it is not directly connected to the water here, a splash is not there and high tide low tide effect is not there, but wind of this area is having droplets, small droplets like a smoke of loaded with chlorides or other salts. So, that is causing deterioration is this, that may cause deterioration in the structure if you have not taken the proper care. Similarly, here you can say the sulphate attack, this structure is this water is having lots of sulphates. So, you can see the deterioration here due to the formation of andesite, this concrete has deteriorated. Similarly, here you can say alkali aggregate reaction, due to this a structure has got cracked like this. So, here I would like to explain here directly we have taken this from the Mehta PK book and Montreux. This is a model actually. So, whatever the things we have discussed, different models here it has been presented nicely. So, this type of the structure you can say this is the structure under the marine condition. Let us say it is a jetty work. So, what we are observing here, this part is continuously under water. So, if it is a continuously under water, so deterioration will be less, and this is a low tide and this is your high tide. So, this is the level of high tide. So, water can go up to this zone, and in low tide this due to the wave this is having a splash on the structure. So, that is going to cause certain durability problem. So, if reinforcement is there, what will happen? There will be ingress of this water, salty water, and in this zone there will be ingress of oxygen also, moisture also. So, that may cause corrosion in the reinforcement if the permeability of the concrete is more. Okay. So, slowly it takes time. Okay. Similarly, if you see the atmospheric zone, so their environment is also loaded with some chloride. So, that will also cause certain corrosion. So, we have to take a special care while we are constructing the structure in marine environment. Similarly, if you see this tide, so chemical decomposition may take place due to CO carbon dioxide oxide that may cause carbonation in concrete. Similarly, Mg ion will attack, sulphate will attack in this zone, and if you see here there is a chances of alkali aggregate reaction that is happening due to chemical decomposition of hydrated cement. Similarly, here because if you have a excess of lime in the cement, that is going to react with the reactive aggregate. Similarly, here in this one, suppose in this zone waves is coming and attacking this, and if this structure is nearer to the seashore, so that water may be having sand and gravel, and that is going to act like a cutting tool. So, this is going to cut this portion due to the sand particle and gravel particle, which is having a sharp edge and more hardness than concrete, and it is going to erode this particle. And this zone, suppose this water is having low temperature, freezing temperature is there, so ice may be there. So, ice may be there. So, there is a phenomena of freezing and thawing. So, that may cause deterioration in the concrete. And lastly, all these things, if concrete this reinforcement is going to get corroded, so this volume will increase. So, after the increase of volume, what will happen? This structure will get corroded. So, due to this corrosion, once again more ingress of oxygen, water will take place, chloride will take place, and due to the penetration of these harmful ingredients, rate of corrosion will increase. So, these are the actions which we have observed how this thing is going to affect our concrete. So, durability is directly related to the permeability. If our concrete has been made giving the due consideration, then certainly it is not going to deteriorate, it will serve the their life. So, if you see here, this is the IS 456, we have 5 exposure conditions, environmental environment. So, we have a mild exposure, moderate exposure, severe, very severe and extreme. If you go to Japani code, they have divided into 3. If you go to Euro code, they have also. So, each and every country they have based on their environmental conditions. So, they have classified their environment in different way. For India, we have divided this structure will be in the 5 zones. It may be even in one place also, that portion may be mild or moderate. Suppose we take the example of Delhi, which I have mentioned in the earlier lecture, like Dwarika. So, ground is having lots of sulphate and chloride more than permissible limit. Okay. And if you consider the slab, so slab is inside your room, it is not directly subjected to carbon dioxide or more water vapor or chloride or sulphate. So, that you can consider mild, but soil depends on the area, we can consider their foundation is subjected to moderate or severe conditions. So, based on that we have to design the concrete. So, mixed proportion we have to take the care, so that our mixed design should be related to this exposure condition. So, these are the exposure conditions which has been explained here. If you see here, concrete surface protected against weather or aggressive conditions except those situated in coastal area. So, that you can say it is a mild exposure condition. Even coastal, this is a coastal area. So, even it is a protected, even it is a surface is protected, if it is in a coastal area, that you cannot consider it is a mild exposure condition. Okay. Similarly, we have a moderate. So, what is moderate? Concrete surface sheltered from severe rain or freezing, while wet concrete exposed to condensation and rainwater. Concrete continuously under water, concrete in a contact or buried under non-aggressive soil, ground or water. So, that condition you can consider it is a moderate condition. So, what is the severe? So, severe we are observing concrete surface exposed to severe rain, alternate wetting and drying or occasional freezing whilst wet or severe conditions. Concrete completely immersed in sea water, concrete exposed to coastal environment. So, all this thing is severe condition. Okay. So, if our structure falls in this category, so based on that we have to plan our design mix. So, similarly, we have very severe conditions. So, what is very severe condition? So, concrete surfaces exposed to sea water, spray, corrosive fumes or severe freezing condition while is wet concrete in contact with or buried under aggressive subsoil or groundwater. So, suppose we are considering the area which is nearer to the coastal area. So, we have to consider the very severe condition. Okay. So, similarly extreme condition. So, that is the maximum condition, surface of members in tidal zone, members in direct contact with liquid, solid aggressive chemicals. So, all these things there. Suppose you want to make a silage which is subjected to aggressive chemicals like we have acids. So, you have to take the special care for design of the mix. Okay. So, freezing and thawing. What is freezing and thawing? Suppose your structure is in Simla or Srinagar, where rainfall, snowfall is there. So, in that time water will enter the pores. What will happen? Water will enter the concrete capillary and it will get frosted. So, after the frosting what will happen? It is going to put a certain pressure on this. So, this pressure what will happen? This will increase the crack. So, thawing means when water will come out, okay, due to the raising temperature. So, that time once again, so freezing and thawing is a cycle. So, once again another cycle of a snowfall or drop in temperature, moisture will increase this crack and once again volume will increase, because the volume of the snow is more than the volume of water. If because water is having a peculiar properties, at 4 degrees centigrade volume is constant, and if you go above the 4 degrees centigrade or down the 4 degrees centigrade, their volume is increasing. So, due to the increase of volume, they are exerting lots of pressure and finally cracks will develop. So, considering all this fact here, what we have to do? We have to make the concrete which is having air entrant. So, generally air will be always there 1 to 2% in the concrete, but if our concrete is subjected to freezing and thawing, in that case what we have to do? We have to introduce the air bubbles. You have to entrap the air in the body of the concrete. So, that what will happen? Suppose any bubbles is here, So, this is a concrete surface. So, if water is going here, so this water will percolate here and this part will be subjected to pressure, and this portion will only get crack. Okay. This portion will get crack and it will join here. So, due to this circular in nature, a small bubbles, stress concentration is not there. So, crack will not further propagate. So, stop that. What codes say, if our grade of concrete is M50 or lower, and if it is made of 20 mm downside aggregate. So, what they say, entrapped air should be 5 plus minus 1%. So, for that we can use the aluminum powder to generate the air bubbles. So, similarly, if our maximum size of aggregate is 40 mm, then we have to put 4 plus minus 1% of air we have to entrap air for 4%, 4 plus minus 1%. So, if your structure is subjected to sulphate, so sulphate will what will happen? That is going to react with the calcium hydroxide and going to produce the anthracite. So, volume of anthracite is very high, and not only that, sulphate is going to react with alumina also, because we have C3A component. C3A component, if percentage is more than 8% in the cement, so that is also going to react with the sulphate ion and going to produce anthracite. So, volume of anthracite is very high with respect to the concrete, and that is going to put pressure on the concrete and crack will develop. Okay. So, here there is a table number 4 in IS 456, we have to refer to understand the exposure or sulphate attack. You download this IS 456, which we are going to study during your design of a structure. So, based on that exposure condition of sulphate attack amount, they have told what should be the type of cement, maximum free water cement ratio, minimum cement concrete, which are required at different sulphate concentrations. So, these concentrations has been given for the if the water pH value is 6 to 9. Okay. So, I will just show you the table number 4, although it is very small, I have directly copied from the IS 456. So, that you download and see in this. So, this is you may not be able to read here properly, but you just download see the conditions. So, let us say our total SO3 is less than 0.2%. So, that case we can use the ordinary Portland cement or Portland slag cement or Portland pozzolana cement, and minimum amount of cement should be 280 kg per meter cube and maximum water cement ratio should be 0.55. Similarly, your concentration is more than 2 here, more than 2 total. So, in that case what will happen? We have to use minimum 400 kg per meter cube of cement, and type of cement means you have to use the Portland cement, sulphate resisting Portland cement or super sulphated cement with protective coating. So, you have to give certain protective coating also, non-permeable. So, minimum amount of cement and maximum water cement they have restricted. So, you have to refer this code while designing the mix. So, if you see the table number 5, once again this has been taken from the IS 456 2000, IS 456 2000. So, what we have seen for mild exposures they have given for the plain concrete and reinforced cement concrete. So, minimum grade of concrete you cannot use less than M20 for even for mild exposure. If it is extreme, minimum grade of cement you have to use M40, you can't use more than M40. Similarly, maximum water cement ratio they have restricted 0.4 for extreme condition and 0.55 for mild exposure condition. Similarly, minimum amount of cement is 300 kg for mild exposure condition and moderate condition. And if you see here, for severe condition 320 kg, very severe 340, 240 and for extreme condition 360. So, this is the things required for RCC work. Similarly, for pre-stress concrete this thing is also grade of concrete has been mentioned, what should be the minimum grade of concrete. So, pre-stress concrete if you want, so you have to refer IS 4 IS we have to use this 1343 sorry IS 1343 2012. So, their requirement you can get from this particular code. So, if you see the IS code, so they talk about they will talk about the cover. So, for meet the durability requirement, if it is subject to mild exposure then 20, like slab you can't put less than 20 mm, moderate 30, so extreme 75. So, like that they have given the durability requirement for cover, clear cover. Similarly, cover is required for fire also. So, like that we have to consider different durability requirements, and next lecture I will discuss how the corrosion is to take place in the reinforcement. So, this thing we have to consider. So, thank you.